All right, now that we've seen conduction, convection, and radiation in real life, in real circumstances, let's get into a little bit more of a better understanding of what we would see maybe on a worksheet or on a test. So again, we've got conduction, convection, and radiation. So to break down what temperature is, everything is made up of atoms, all right? And all atoms are vibrating. When something gets really hot, it vibrates really, really fast, right? And when something gets really, really cold, the vibration slows down. And eventually, if you made it so cold, the vibration would completely stop. So when we measure temperature, all we're really measuring is how much an atom in a certain area is vibrating, all right? If it's a high temperature, that atom is vibrating a lot faster than something that is in a cold area. Like snow would vibrate the atoms are vibrating pretty slowly there, okay? So that's all that temperature really is. And we have to know that energy always goes from a high place to a low place. Now, when I say from a high place, I don't mean like a cliff or a mountain. And when I say low place, I don't mean like a valley or like the bottom of the ocean. What I mean is energy goes from high to low. So I'm warm compared to the table, right? So if I put my hands on the table, the heat is then flowing out of me and going into the table, all right? So energy flows from high to low. So like the sun has a really tremendous amount of energy. It's extremely hot. The energy from the sun is flowing outward through space, and it's using light or radiation. And that energy is flying out until it hits into something like the earth, and it heats it. So it goes from high energy to the sun to low energy on the earth, heating the earth, all right? So it always flows from high numbers to low numbers, or from high energy to low energy. So a review about convection. Let's imagine we had a shoebox. We pumped 2 holes into the top of it, and then we put a tube above those 2 holes. I put a candle in there, light the candle. This is a bad idea, first off, just because you don't want to have fire inside of a cardboard box, but just for the example, follow through. If we have a candle, watch, I'll light a match. So in this case, I've got fire, and watch where the fire wants to go. So we have, we'll just make sure we don't set off the school fire alarm. We have heat, and you could see it rising upward. Candles literally show us convection. So the heat rises upward. So what would be happening here? Put this in a safe spot. The heat above this candle is going to rise up through here, and we can't just like take all the air out here and have no air left. So air is going to flow in through this tube, and we're going to create what's called a convection current, where heat rises above the flame, and then the cold air sinks in, moves through here because all the air is leaving here, so it has to replace the air, and then it heats up and rises out again. This can happen in gases, or this can happen in liquids. So when you boil water, you can actually, if you look at the water before it boils, you'll see that there's these little currents of water rising and sinking, where the heat rises and the cold sinks. And it's all about density. Low density, when the air expands or when the water expands, it rises. And as it cools down and contracts, it sinks, okay? So where do we see this? If we cut the earth in half and we expose the inside, we would see it has an inner core, a liquid outer core, a mantle, which is kind of like this like viscous rock, which just means like a rock that can like flow over time because it's so massive and so warm. And then we have the crust, or what we call the lithosphere, right? So where we have heat in the inside of the earth, we have rising convection current. So heat rises up and then it cools as it runs across the lithosphere, cools, sinks down, heats up again, heats up, hot, rises. So we have convection that's going on there. Just to be clear, convection in the mantle is not this simple. It's more complicated, but for the sake of high school earth science, this is what we'll be showing you, all right? So, conduction is the example that I gave before with the desk. If I, which I am a solid, touch this solid, my heat is then transferring into this solid, and then the heat is transferring through the table, out and around. So conduction is what happens when you physically touch something. You can feel conduction when you touch a hot pan and it's really, really hot. So it sends energy into your hand really, really quickly. You pull away real quick. Don't try it. It's dangerous. Okay. So another example of conduction is going to be when we hold a metal spike or some type of heat over a flame. That heat is going to transfer through this metal rod until it reaches our fingertips, and then we're going to drop it and it's going to burn us. But I also want to show that we have all different types of heat transfer in just this image. If we have a flame or a light, just like the sun, flames or light release radiation. Radiation is a form of heat in the form of light. Not only do we see radiation here, but we can see that the air inside the flame is rising, which is convection. So convection is when heat rises and cold things sink down. And we also have conduction, which is where heat travels through solid objects. Okay? So we have conduction, convection, and radiation. So the biggest form of radiation we have is from the sun. Anything that emits light has radiation in it. Something that may surprise you is that I am glowing right now. You may not be able to tell, but that's because you can only see visible light. You can only see from the red to the violet of light. We can't see below red and we can't see above violet. But below red is this thing called infrared. So I'm actually glowing in infrared. That's what night vision cameras detect. And infrared is going to be heat emitted by my body. All right, so a way you can think about that is when you turn on the toaster oven in your house, eventually, once it gets really, really hot, it will glow the orange red. But while it's heating up, it still doesn't glow, but if you touch it, it's hot, right? And you can feel the heat coming off it, even if you don't touch it. So the point is that heat is infrared, and if it gets hot enough, the object will become red. And then as it gets hotter, eventually it'll glow white. And if we can make it crazy hot, it might glow a little bit blue because the energy is getting higher and higher and higher and higher and higher. Just like how we were talking about red shift and blue shift. Red shift is lower, red light is lower energy, blue light is higher energy. Okay? So radiation is just heat or light or any type of radiation or electromagnetic energy coming out of an object, and it's based on its temperature. All right, so here's the little review. From the flame, from the light it emits, what form of energy or heat transfer is that? So flames give off light and they are radiation, and you can even see the radiation in the form of these waves. That's usually a clear sign that we have radiation. If something's coming out squiggly lines, that's the infrared, the invisible light that is heat. But you can also see boiling water here. The heat rises, and then the cool water sinks and heats up, and then it rises and it cools down, and it sinks. This is a convection current, so this is convection. Also, the air around here is rising. We're not seeing it, but heat above a fire rises, cools down, and that's also convection. So convection's in the liquids and the gases. Radiation's just light. And then finally, there's a solid here, the metal handle, which is getting heated up by the fire, and that heat is spreading through a solid, the solid metal handle. So this is going to be conducting heat, or conduction, just going into the hand, and eventually maybe it may be too hot to hold due to that conduction. All right, so those are the three forms of energy or heat transfer, and that's really all you've got to know for the basics of heat transfer.